Good day and welcome to our next lesson. In keeping with topic 1, we are now going to progress to the next part, and the next part on topic 1 comes up with the concept of still surds. Topic 1 numbers, we are now moving to rationalization of surd denominators. As we have done in the past working with surds, we are going to maintain the rules but try to rationalize surd denominators. In mathematics, we are sometimes required to leave an answer in a convenient form. Having a fraction with an irrational denominator is quite an untidy manner of leaving an answer, and normally in the examinations they will ask you to rationalize the denominator. In order to neaten up such answers, we rationalize all surd denominators. Now, if you recall in the past, a denominator comes from the fraction, where the top is the numerator and the bottom is the denominator. The process we use here is quite simple. Consider the fraction 4 divided by root 3. In order to rationalize the denominator, we multiply the fraction by 1. Now some of you might be thinking, if I have to multiply the fraction by 1, it's not going to make much of a difference. But there's a few things that I want you to watch out here. 1 is an amazing number. This one over here. It's what we like to refer to as a magical number. Consider the fraction 4 over 3 again. If I consider 4 over 3, 4 over 3, to bring it down to rationalize, I multiply it by 1. 1 can be written as a variety of forms. It can be written as 5 divided by 5. It can be written as 12 divided by 12. This is equal to 1, that is equal to 1. If I go further, 1 can also be written as root 3 divided by root 3. So when we come back to the question of this fraction over here that we have to rationalize the denominator, we can multiply it by 1, which means I can multiply it by 5 over 5, 12 over 12, or even root 3 over root 3. Now let me go back and rationalize the following denominator, 4 divided by root 3. Whenever I take 4 divided by root 3, I said I will multiply it by 1. Coming back to what I said before, if I multiply it by 1, not much of a difference. But remember, 1 can be written as a variety of forms. It is up to you now to decide how you are going to go about writing this one. I will not use that. I will not use that. If I look at root 3 over root 3, that is the same as 1. Why I would choose root 3 over root 3 is because this denominator here is root 3. So ultimately I am saying that is equal to 4 divided by root 3 multiplied by, instead of writing 1, I write 1 as root 3 divided by root 3. All I'm going to do now is to multiply this out. 4 times root 3 is 4 root 3. Root 3 times root 3 I write down as root 3 times root 3. Now there's a thing that I need to remember. When it comes to root 3 multiplied by root 3, your answer simply here is 3. It may be difficult to understand now, but when you come across or when you go to the section on exponents, you will notice that this is equal to 3. So whenever you see something like this, root 2 multiplied by root 2, the answer is always equal to 2. There are a few ways that I can prove it to you, but for now, let's take it for granted that this is going to be the answer. To continue, 4 multiplied by root 3, I cannot do anything with it, but root 3 times root 3 is equal to 3. And this is your final answer. I cannot simplify any further, and if you have a look at this denominator here, it has been rationalized. Quite a simple process. Let us go further into examples that are a bit more trickier than this, but nonetheless still easy. Another example. Rationalize the following denominator. 2 divided by 3 root 5. Now I come across 2 divided by 3 root 5. This is slightly different from the previous example because I have here 3 multiplied by root 5. But nothing is going to change. Step number 1. Multiply by 1. This number 1 can be written in a variety of forms. I have to choose the most appropriate form. I will say this is equal to 2 divided by root 3 multiplied by. Now before I go down here, this one, the 1 is the same as 3 root 5 over 3 root 5. That is still equal to 1. Also, what is equal to 1? Root 5 divided by root 5 is also equal to 1. Now it's a matter of which one do I choose. If I look at this denominator, the only thing that concerns me is the root 5. That's the part that I need to rationalize. So I will choose root 5 divided by root 5. For those of you that choose 3 root 5 divided by 3 root 5, you will still get the correct answer, but you might require just one more step of simplification. Nonetheless, we are going to go ahead with our next step. I multiply. 2 multiplied by root 5, 3 root 5 multiplied by 3 root 5. 2 times root 5 is 2 root 5. 3 root 5 multiplied by root 5 is 3 root 5 times 3 root 5. Not a problem. The numerator, nothing much I can do. But if you have a look at the denominator, look at root 5 multiplied by root 5. Now that will distinctly give you the answer. It's 2 root 5 divided by 3 times root 5 times root 5 is equal to 5. And 3 times 5 is 15. And this is your final answer. Before leaving off your answers, please ensure that this fraction cannot be simplified any further. In this case, it cannot. Have a look at this example. Quite a simple example, but again, let's progress to something else. Conjugate pairs. I'm still dealing with rationalization of denominators. Consider the expression 6 plus root 3 into 6 minus root 3. This is a conjugate pair. The brackets are identical apart from the sign in each bracket. The brackets are identical apart from the sign change. If you look at this sign and that sign, one is positive, one is negative. Now let us look at what happens when we multiply these brackets out. You can use any method that you want to use. The FOIL, the half moon, doesn't make a difference. If I have to multiply this out, I will start off by saying 6 multiplied by 6 is 36. Now some of you might go this route by saying 6 times root minus root 3. 6 multiplied by the negative root 3. That's the way that I will go. Some of you might go root 3 times 6. Doesn't make a difference. That becomes 6 root 3. Your next step, you can go ahead and say that multiplied by that is minus 6 root 3. And your last one is root 3 times root 3, which is equal to 3. Please take note of the sign. The last part was the square root of 3 multiplied by negative the square root of 3. So that is why I get the answer negative 3. If I look at this step, plus 6 root 3 minus 6 root 3 cancels off. 36 minus 3 is equal to 33. Simple enough. Now, where do I go about using these conjugate pairs? Let's look at an example where I am forced to use a conjugate pair. Worked examples. Now guys, I want you to pay careful attention to these examples. I'm not doing too many of them, but you will have a lot of them in terms of the activity that you are about to do. The question in the exams will read, rationalize the following denominators. Question number 1. 4 divided by 2 plus root 3. 4 divided by 2 plus root 3. In order to go about doing this, I have to take this expression and multiply it by 1. Correct. How can I write the 1? Now in a step like this, I have here 2 plus root 3. 2 plus root 3, if I want to use that and say, how do I go about writing that as 1? It simply becomes 2 minus root 3 over 2 minus root 3. Now guys, don't get confused about this. I want you to pay careful attention to what went on here. I am using conjugate pairs. The reason I am using conjugate pairs is, as in the previous example, I want the denominator to be rationalized. 1 could also be 2 plus root 3 over 2 plus root 3. But if you notice, if I put 2 plus root 3 over here, there's no way that this denominator, if I multiply it out, will become rationalized. So get into the habit of first finding the conjugate of this denominator here. And the conjugate of this denominator is 2 minus root 3 divided by itself. So you find this blue part is equal to 1. The next step, guys, let's multiply out. It's 4 multiplied by that. It's this multiplied by that denominator. So it's 4 times 2 minus root 3 over 2 plus root 3 multiplied by 2 minus root 3, as shown over here. I simply multiplied out. Now guys, sometimes you might not be required to simplify the numerator. Not a problem. But you have to simplify the denominator. In this case, I simplified. 4 times 2 is 8. 4 times minus root 3 is minus 4 root 3 divided by. Now I skip these steps here, and you can do so also once you get used to it. Watch what happens over here. 2 times 2. Right, there seems to be a mistake in my answer here, but nonetheless I'll sort that out now. Root 3 times negative root 3 is minus 3. Now I want you to watch the middle step. This becomes plus 2 root 3. That becomes minus 2 root 3, which basically cancels off. So, to cut a long story short, multiply the first with the first, multiply the last with the last. Now coming back to my slight error here, which I will change now, 2 times 2 is equal to 4. So it becomes 4 minus 3. And if I want to simplify this, guys, it is quite easy. I will put the solution down here. It's equal to 8 minus 4 root 3. 4 minus 3 is equal to 1. So your final answer here is 8 minus 4 root 3. And that's the answer you end up in this case. A simple process. Guys, what you need to ensure is that you have the correct conjugate. In the exams, if you use the incorrect value over here, that is where the marker will stop marking, which means highly unlikely that you'll get any marks for this question. That's the importance of getting the correct conjugate. Slight error, ignore the next part. We'll go down to question number 2. In question number 2, rationalize the following denominator. Haha, something a bit more difficult. Guys, I've got 4 divided by the square root of 7 minus the square root of 3. I like this. Look at this denominator. If I want to rationalize, I always multiply by 1. And in this case, if I'm multiplying by 1, I'm going to look at the denominator. I want to know what is the conjugate of this denominator, and the conjugate means that the sign in between simply changes. It's a negative, it becomes a positive. And ensure that you have a positive over the positive, or the conjugate divided by the conjugate. Don't go around swapping signs, that's unnecessary. This blue part is equal to 1. My next step will mean that I have to multiply out. Multiply my numerators, multiply my denominators. If I multiply the numerator, I end up with 4 into root 7 plus root 3. Root 7 minus root 3 into root 7 plus root 3. Numerator, I don't have to worry about. But watch the denominator, guys. I said skip everything else. It's the first multiplied by the first. That's where I get the 7. And negative root 3 multiplied by a positive root 3 is equal to negative 3. And if I simplify here, guys, I end up with 4 root 7 plus root 3, or 4 into root 7 plus root 3 divided by 7 minus 3, which is equal to 4. And immediately you'll notice that 4 cancels off with that 4, which means my final answer is the square root of 7 plus the square root of 3. Quite an impressive example. This at level 2 should be just about the most difficult example that you will come across. I don't think that any examples will be much more trickier than this. But guys, please ensure that you know not only the difficult ones, but also the easier examples. I'm going to leave you for 1 second just to ponder this example. Ensure that you understand the full idea behind it. Now that you are happy, we're going to go on to the next part, which includes an activity. I'm up quite quickly, very eager to do number 6. Rationalize the following denominators. Guys, as usual, in this case you are going to rationalize each one and then come back to the examples. Example number 1, example number 2, a bit more difficult than example number 1. And as you can see, as we are progressing, guys, the examples are getting a tad more difficult. Example number 7, still a bit easy. Example number 8, not so bad. Example number 9, and finally example number 10, which should be the toughest of all the examples. But as I said in the past, don't worry much about it. If you can do one example, you can do any example. Now guys, spend a moment. I want you to copy these examples down. Copy each example down. And you are to do the examples first prior to continuing with the answers. For those of you that are slow in copying down, please press pause. Once you have finished off, then you may continue. Guys, let us continue with the example. Activity 1. Rationalize the following denominators. On this part, I'm going to go a bit more faster, but ensure that you have the correct answers. Question number 1. 3 over root 6. In this example, guys, we have to rationalize, multiply by. What do we multiply this by to rationalize? You multiply it by root 6 over root 6. 3 times root 6 times root 6. This is equal to 3 times root 6 is 3 root 6. Root 6 times root 6 is 6. Now don't leave your answer like this, guys, because straight away if you look at this example over here, I can simplify. Now for those of you who do not simplify, you are going to be losing marks. So please ensure that you say 3 can go there 1 time, 3 can go there 2 times. So your final answer is root 6 over 2. Example number 2. Remember example number 2, we multiply by 1. And in this case, you can multiply by 9 root 2 over 9 root 2, not a problem. But I would prefer that you multiply by root 2 divided by root 2. Again, guys, multiply. Multiply. And if I'm going to multiply here, it's 5 times, where did that come from? 5 times root 2 over 9 multiplied by root 2 times root 2, remember, is 2. And this answer here, guys, is 18. So it's simply equal to 5 root 2 over 18. How about that example? Quite a simple example, agreed? Perfect. Guys, let's go on to number 3. In number 3, again, you shouldn't have a hassle, even though the numerator is a little longer. It's 3 root 5 over 5 root 3. But what did I tell you? You multiply by 1. But I'm going to be using root 3 divided by root 3. Where did I get that from here? Please don't go and multiply by root 5 over root 5. You're not interested in that one. You're interested in rationalization of the denominator. Multiply out, guys. Multiply there. Multiply there. This is equal to 3 root 15. Where did this root 15 come from? If you go back to the third laws, you will notice that root 5 multiplied by root 3 is equal to root 15. And the denominator, root 3 times root 3 is 3. 3 times 5 is equal to 15. Now guys, this 15 that I got from here comes from this step over here. This becomes 5 times root 3 times root 3, which is 3, and that's where I got this 15 from. How are we going, guys? 3 out of 3. Perfect. Going now to the next example. Oh yes, thank you very much. I forgot about that. Simplification. 3, 15. 3 can go into 3 1 time. 3 can go into 15 5 times. And that's the answer I end up with. Root 15 divided by 5. Who do I have to thank for that? Number 4. Number 4 is a bit longer. When it comes to number 4, remember, guys, we have to multiply. Negative 5, 2 minus root 7, I have to multiply by what? I need to get the conjugate pair. The conjugate of this is 2 plus the square root of 7. So it's 2 plus the square root of 7 over 2 plus the square root of 7. And guys, multiply, multiply. You should end up with that step. Right. From that step, we said simplify the denominator. Numerator you can leave as so, just to ensure that maybe something will cancel off. 2 times 2 is 4. That times that is minus 7. And your final answer is minus 5 into 2 plus root 7 over minus 3. Correct. 6 more to go, guys. Number 5. Number 5, conjugate. I need the conjugate of this. This is equal to 5 divided by 3 plus root 5 multiplied by 1. And in this case, 1 is equal to 3 minus root 5 over 3 minus root 5. Multiply, multiply. You should end up with this step, which will now lead you to that step and lead you to the final answer. Is that correct? Correct. Number 6. I'm not going to go over number 6 much, exactly the same as the previous examples. Remember number 6. Multiply by 1, the conjugate pair is 3 plus root 5 over 3 plus root 5. This is the important part. I always tell you that. Multiply out. That's your step. You end up with something like that and that. Now again, don't leave your answer as so, because you can see you have something cancelling off here. And that is equal to minus 3 minus root 5. Nothing will, or you will not lose any marks if you simply leave the negative on the outside. That is also acceptable. Okay guys, how's that? Is that fine? Remember, you can pause at any time. You can go back a few steps just to follow what needs to be done. Question number 7. Question number 7 is a bit different because now you find the root first minus 2. Does it make a difference to us? Not at all. You take the number, or you take the fraction, you multiply by 1. In this case, it's simply the sign in between that changes. This becomes a positive. And you do the whole long process again by simply multiplying out. Multiply. I'm going to leave the 7 here, just in case I can simplify it with something else. The denominator, that times that, is 7, minus root 2 times, why do I keep making this mistake here, guys? Times that. Minus 2 times that is equal to 4. Lucky I checked this one up. 7 minus 4 is equal to 3. And your final answer here is equal to, all divided by, and remember this one here is equal to 7 minus 4, which is equal to 3. Please double check your answers. For some reason or the other, I am not multiplying correctly. But nonetheless, this is the answer. Let's go on to number 8. Number 8, a bit better. There's your fraction. I need to rationalize the denominator. I cannot break them up and multiply by root 5 over root 5. Ain't going to work. I have to multiply it by the conjugate. And remember, the sign changes. That's all that changes. There's it here. 2 minus over 2 minus. And now, guys, I multiply out. Numerator, I multiply out. Denominator, I multiply. And again, guys, watch what I did here. I multiplied this out. 3 times 2 is 6. 3 times minus root 5 is minus root 5. There times there is minus 2 root 5. And minus root 5 times minus root 5 is minus 5. Denominator, 2 times 2 is equal to 4. Root 5 times negative root 5 is minus 5. And if I simplify this, guys, minus 3 root 5 minus 2 root 5 is like saying minus 3x minus 2x, which is minus 5x. And in this case, you'll find it becomes 6 minus 5 is equal to the 1. Minus 3 root 5 minus 2 root 5 is minus 5 root 5. And of course, the 4 minus the 5 is equal to minus 1. And of course, in this case, because of the minus 1 here, you can go in and say this is equal to minus into 1 minus 5 root 5. For those of you who want to, you can go in and say, but this here is equal to minus 1 plus 5 root 5. That is also acceptable. My calculator must have not been working this day here. 2 times 2 is equal to 4. Don't know what calculator I was using. Nonetheless, let's go on to example number 9. In example number 9, you multiply by the conjugate. And what did we say the conjugate was going to be? Yes. 3 minus root 5 over 3 minus root 5. Guys, multiply out. I'm going to double check this one just to ensure I didn't make the same mistake all along. It's that times that. Two denominators multiply together. 2 times 3 is 6. 2 times minus 5 is minus 2 root 5. Minus 7 or minus root of 7 times 3 is minus 3 root 7. Minus 7 times minus 5 is minus root 35. Over 3 minus 5, that times that is 3, that times that is minus 5. And if you look at this example, guys, there's nothing much I can do with this one here except to go ahead and say 3 minus 5 is equal to minus 2. So the whole answer can go further, and you can say this is equal to 6 minus 2 root 5 minus 3 root 7 minus the square root of 35, which I'm not interested in so far because I simply was asked to rationalize the denominator, and this is divided by minus 2, and that can be your final answer. Ignore that answer. Let's go on to number 10. In example number 10, as I said, just about the most trickiest example, but let's go ahead and check if we got it right. If I look at this example here, I have to multiply by the conjugate. There's your fraction multiplied by the conjugate. The only thing that changes is the sign. There's the change of the sign. I multiply out, I multiply out. Numerator times numerator. Denominator times denominator. Root 3 times root 3 is 3. Root 2 times root 2, where one is a negative, one is a positive, is minus 2. And this here, guys, is equal to 3 minus 2, which is equal to 1. I multiply this out. Root 3 times root 3 is 3. Root 3 plus root 2 is root 6. And your answer here ultimately is 3 plus root 6. And that is 100% correct. Sorry about that, guys. That is 100% correct. I don't think you should have a problem with these exercises. Now, guys, when this activity, or when you do this activity, ensure that you had all 10 correct. Ensure that you understand all 10. It's just a matter of figures changing, but everything else remains the same. With that, guys, it is the end of surds. The next portion that we'll be dealing with will be exponents. So I'm glad that you understood this, or I hope that you understood it.